All right, a few more questions left. Guys, don't worry about this word minimum right here. I know it's a little bit confusing. It just means like the least amount of x's, the degree, the least degree that we're looking for. So I want you to just eliminate that word because it's been confusing very, very much to a lot of students. So what is the degree? Remember, we're going to count the x's. So we got an x here, we got an x here, we got an x here. We're going to count the multiplicities. This is a slice, so that's a 1. This is a bounce, so that's a 2. And this is a slice, so that's a 1. So I'm going to count the x's. So I got 1, 2, 3, 4. So the degree is 4. Okay? Now let's take the zeros. Again, we're going to have an x equals -3, x equals 2, and x equals 5. And their multiplicity, we just did that here. At this one, we move this to the side. All right, here at this one, I got a slice, so that's a multiplicity of 1. Here I got a bounce, so that's a multiplicity of 2. And here I got a slice again, so that's a multiplicity of 1. Okay, so this is a multiplicity. Remember, multiplicity means how many x's or how many answers do I have in one point. And then write a possible equation. So remember that if this, what you see on the graph, it's x equals -3, in the factor form, it's going to be a +3. If this is what you see on the graph, okay, which is x equals 2, it's going to be x minus 2, the opposite. And here, if you see x equals 5, it is going to be x minus 5. Why? Because if x equals 5, I need to move it this way, which means I got to subtract the 5 from both sides to make it x minus 5 equals 0. Okay, and I do it for every single one of them. Now the multiplicities, for -3, it's 1. For 2, it's 2. And for 5, it's 1. So your final function would be x plus 3, x minus 2, and so on, okay? All right, moving on to the next question. All right, list zeros with their multiplicities polynomial function. Once again, we are going to take each of these thingies and equal them to 0. I'm not going to be rewriting it. We're going to take the 3 and equal it to 0. That's not a true statement. There is no x there, so that just goes away. We are going to take x plus 5 and equal it to 0. X will equal -5. We are going to take x plus 2 and equal it to 0. And x will equal -2. And we are going to take x minus 1 and equal 0. X will equal 1. And lastly, x minus 5 equals 0. X will equal 5. Okay? Now, their multiplicities here. Here you got 3, so you got a multiplicity of 3. Okay? So multiplicities are the exponents on the top of the parentheses. So multiplicity of 3. And then for x plus 2, the multiplicity is 4. And for x minus 1, the multiplicity is 2. And for x minus 5, the multiplicity is 1 because it's not written. And when it's not written, it is assumed. Okay? All right, next question says, the student was told to sketch the graph represent a polynomial function. The function says odd degree, which means the ends go in the opposite direction. All right? With a negative leading coefficient, that means the ant tail goes down. And the x values are approaching negative infinity. The function is approaching positive infinity. There are 4 roots with multiplicities of 1 and 2. So 4 roots, I got 1, 2, 3, 4. And what are they multiplicities? Slice, 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 bounce. Okay? So yes, 4 roots. Roots means zeros means x-intercepts. And their multiplicities are 1 and 2. Very good. Okay? So that also checks off. And this is checks off. And the leading coefficient checks off. And then it says as x approaching negative infinity. That means when x is going here, it's saying that the function is approaching positive infinity. Function is going up. That is also correct. So this is a correct graph. So again, when x approaches negative infinity, that means when my function is traveling this way, where when my x's are traveling to the left to negative infinity, where's my function going? Up. Okay. All right. Next one is given the graph of the following polynomial, identify the key characteristics. All right, so I have degree. So let's see, I got 1, 2, 3 zeros. What is their multiplicity? Bounce, slice, and a slide. Remember, slide is 3, bounce is 2, and a slice it's 1. So how many is it together? 2, 3, 6. So the degree is 6, okay? Because you're just adding their multiplicities. Okay, leading coefficients, always the ant tail. Where is my function traveling? It is traveling up, positive. All right, interval increase and decrease. That it means you are on a roller coaster once again. I know you guys love that. And you are riding. So I'm riding down all the way to this point. So decrease means negative infinity to negative 3 because you're coming from here to here. Okay, it's decreasing. After that, after the same point, now you're going to go up. You're going all the way up to this point, okay? So that point is negative 2. So you're going to use the same point you ended with to start your increase, negative 3 to negative 2. After negative 2, guess what happens? You are riding down again all the way to what point? Looks like 1. You're going to use the same point for decrease, negative 2 to 1. Now you go writing down again. Well, guess what? At 1, you are going to go back up, and you're just going to keep on going. So at 1, you are going toward infinity, okay? Because it's this way. That's what you're doing, all right? So once again, when we do that, just think about yourself and as you go. And axis of symmetry means in the middle of those mountains, that's the point where you're switching, going down or up, okay? Now for positive and negative, it's a little bit different. Positive and negative, it's based on your x-axis. So here you have your x-axis. Positives are all these numbers, negatives are all these numbers. So I am going to do positives first. So I got this one, this one, this one, it's all positive. So I could say negative infinity to negative 3, from negative 3 to negative 1. So from here to here, and then from here to here, it's all positive. And then where is positive again? From 4 to infinity. And then negatives are going to be from negative 1. This is negative 1. All these are negatives all the way to 4. So this piece right here, from negative 1 to 4, are all negative values. They are below 0, okay? All right, and then states their zeros and their multiplicity. So, of course, zeros means not a number 0. It means x-intercept. So I got x equals negative 3. And the multiplicity, it's 2 because it's a bounce. Then I have another 0, x equals negative 1. And the multiplicity, it's 1 because it's a slice. And then lastly, up here, I got x equals 4. And it is a slide, which means it's a 3. Slide means it goes and it crosses, okay? And then write a possible function. Again, we're going to take this 0, x minus 3, and going to move it to the left and make it an x plus 3. We also are going to put the 2 outside for a bounce. Here, we're going to have x equals negative 1, so in the parentheses, it's going to be plus 1. And 1, it's your multiplicity. Again, we don't really write that 1. It's always assumed, okay? I'm writing it just for visual memorization. And then x equals 4, so this is going to be x minus 4, and the multiplicity is 3. So this would be your f of x function, okay? All right. And then moving on to the next question. All right, describe each function's end behavior. You can graph it to help yourself visually if that's what it helps you. I do not need to graph it. What I can do is I can figure out that this has a leading coefficient, okay, that is positive. And that I also know that this is an odd function. So these two things tell me that. Tells me the leading coefficient is positive, means that my function will end somewhere here, okay? I also know it's an odd function, which means the other end will be opposite. All right, Now, it doesn't matter what you draw like this because you're looking for end behavior. So I am only going to tell you that the x goes toward positive and the x goes toward negative infinity, and then what happens to the function. It's always the same setup, okay? Now, I'm always going to look at positive leading coefficient means the right side, which means this. I'm going to start with that. I know that this is positive leading coefficient because it has a positive number 5 in the front. So that means on the right side, my function goes up. Because this is an odd function, automatically, the other one has to be opposite because this one is going down on the left, okay? So I do not need to graph that, but hold that if you need to. Write it down. Now for the next function right here, again, I'm going to look at the same thing. My leading coefficient, it's negative. LC stands for leading coefficient, it's negative, and my function, it's even. So what does that tells me? That tells me that my far end, my ending point, it's here. This is my negative leading coefficient, but since it's even, this one also is down here. So that means that on my right side, as I'm going toward positive infinity, my leading coefficient, it's negative. Okay? That also tells me that the other end will also be negative because my function, feet, got to go in the same direction because I have an even function. Okay? All right, moving on to the next one. All right, so here it says these are zeros. Which one matches? Okay, so if I take x equals 9 and put it into a factor form, I'm going to switch the sign. If I take x equals negative 5 and put it in a factor form, I'm going to have a positive 5. So let's see which one eliminates that. So these two are a no-no. So now I also have a 0, and I'm wondering where I got it from since I don't see the two factors. Well, you got a 3 and you got a negative 3x. If I take 3, if I go backwards, and if I set this equation a to 0, 3 equals 0, x squared minus 9 equals 0, and x plus 5 equals 0, okay? First of all, I can right here already see that x squared could not be it because I only have x minus 9, so this is not it, so it must be c. But I want you to understand where is that 0 coming from. The 0 is coming from that number in the front, which is negative 3x. If I equal this to 0, this piece right here, I will divide both sides by negative 3, and x will equal 0. Okay? All right. Next question. All right, guys. So this one again, which one is it? So we are going to take the zeros. So these are your zeros. So x equals 4. Right? And we're going to put it in a factor form, which means x minus 4. And we're going to take and that's with the multiplicity of 2, right? And then we are going to do x equals negative 1. And we're going to put it and add 1. So as you notice, it cannot be the 2. And it doesn't say, so that means there's a multiplicity of 1 right here as well. So that means it cannot be the 2 either. Now, it doesn't have any other zeros, right? So we are between question A and question B. It cannot be B because we would have to equal negative 2x equals 0 divided by negative 2. So x will equal 0. And this does not state that. We don't have that. So it has to be A because if you equal 4 to 0, it's just non-existing. So the only two zeros that you're going to have out of it, it's negative, it's going to be positive 4 and negative 1, right? So it has to be answer A. Okay? Okay. Moving on to the next question. It is going to be question 25. It says which one is true about it. First of all, degree, even or odd. Well, this is even because footsies both go in the same direction. So I'm going to scratch out the last two, okay, as an odd. Now, between even the two even functions, we're going to look for the leading coefficient. Remember, the leading coefficient is the far end of your function. Since it's going down, it's negative. So it's not going to be answer A. It is going to be answer B. All right, the next one talks about determine the degree and leading coefficient for each. Obviously, this one has two different ends of the function. So this is odd. And the leading coefficient, which is the far end right here, it's going up. So the leading coefficient is positive. All right. The next function, both ends are going in the same direction. So both footsies are going in the same direction, which means this is an even function. And the far end of the function is going down, which is negative leading coefficient. Okay. All right. Next question 28. Question 28 has a graph and it's saying which of the following could represent that? Well, first of all, two footsies going in the same direction, which means that this is an even function. So I'm going to scratch out any function that has an odd number to an exponent, okay? Now I'm left with 1, 2, 3. Now I'm going to look for a leading coefficient. Leading coefficient, which is the far end of the function. It's going up, which means it's positive. So it means that I cannot have a negative number in the front. So I can't have this and I can't have that. So it has to be answer D, okay? All right, so here, next question 29, Isaac sketch a polynomial, g of x, with a total of 3 real zeros. So this is very important. And then any behavior described as when x approaches positive infinity. That just means when x approaches positive infinity. The g of x, it's approaching negative infinity. That means that the leading coefficient is going down. So here it's a positive, so we can't have that. Here it's a positive, so we also cannot have that. So we got A or B. Now we're going to find 3 zeros and confirm. So here you got a slice, so that's 1 0. Here you got a slice, that's a 1 0. And here you got a slice, that's a 1 0. That makes it a 3. For B, you got a bounce, that means 2 zeros, slice, which means 1, and slice, which means 1. So that makes it a 4. We only got 3 zeros, so that means A is your answer, okay? All right, now the next question is question 30. It says, which graph would represent that? So I would always, if you're given an actual graph, I would definitely graph it and then compare it. Now, from just looking at the graph, I can say that this is an odd function and it has a negative leading coefficient. So all of them are odd, but negative leading coefficient means that the ant tail goes down. These two go up, so it cannot be C or cannot be B. Now, how do I know if it's A or D? It doesn't tell me how many zero it has. So what I could do is, again, graph it for your references. But what I can do is try to see and solve it. So I will divide it by x, negative x actually. I will get negative x in the front. And then what's left would be x squared plus x minus 5. So I will just take a greater common factor out. I can already tell that because this is a quadratic equation, what I want you to see, the difference is that you got a slice here and a bounce. Bounce means that there is two the same answers, right? I'm just giving an example, right? Here you got a slice, slice, slice. So I can tell I'm not going to get a bounce out of this. I'm not going to get two the same answers. But if I would want to solve it, I would say negative x equals 0, so x equals 0. So that's one of my answers. And right there, I stop you right there. That would mean that at 0, there is one answer. Here at 0, there's 2, which is not true. So I would have to pick A. But just to confirm, because that at 0, we don't have a bounce, right? I would want to make sure that you confirm it using decimals, okay? All right, moving forward to question 31. So you are going to use decimals for this one. Let's see. So I'm just going to let you know that this is a cubic function, but if it's not listed, I'm going to show you how to find out if you're using quadratic progression equation or cubic. You're going to go to table and you're going to plug in these numbers in. So you're going to have 1, 2, 3, 4, 5. All right, and then here we are going to have a 1.7. We're going to have 4.4, 5.3, 4.8, and 4.1, and 3.1. All right, now if you don't know which equation to use, first I'm going to go with quadratic. So y1 is squiggly, you're going to have ax squared 1. We put 1 to reflect the table, right? So that's this one right here at the table, so the computer knows what to read. Then plus bx 1 plus c. So this is my quadratic equation. Now I'm going to plug in a cubic as well, because I don't know which one am I using. And then ax cube 1 plus bx squared 1 plus cx1 plus d. Now, for me to figure out which I'm going to use, I'm going to look at this r value like right here. And whichever number is closer to 1 is the equation that is appropriate for regression equation to use. So since this is 0.91, this is 0.99, this is a better probability, so we are going to use a cubic function, okay? Now, when we plug that in, cubic function has one extra x, and it has a constant as a d. You are going to get these numbers right here. This is your a, this is your b, this is your b, your c, and your d. And we're going to go back here, and we're going to use these numbers, and it says determine the regression equation, round it to the nearest hundreds, okay? So we're going to round it 2 places after. So this is a cubic, just so you know. And we're going to round it, the equation to 2 places after. So this is going to be y equals 0.10 x cubed minus 1.22 x squared plus 3.8. Let me see. What is C? 3.80, I guess. 3.80 right here. X, and the last one would be 1.71. Now, use this regression equation to predict the number of visitors in the park in 2013. This shows from all the way 2006 to 2011. So what we're going to do is figure out from 2011 to 2013, how many years is it? 2 years. Okay. So we're going to go ahead and plug the 2 years into decimals. So we're going to write down that equation, y equals the way we want it rounded up. So it's going to be 0.10. And now instead of that x cubed, okay, we are going to plug in our 2 and cube it. Then the next value is b, which was -1 point. We rounded up to 2, and then it's going to be 2 squared. Okay. Because again, the equation was ax cubed and so on. And then you're going to do a positive value of c, which was 3.80, and then we have our 2 in there, and then lastly your d, which is 1.71, and you get 5.23. So 5.23. So it says how many numbers of visitors to the park in 2023 was 5.23,000. Okay, tens of thousands. Okay. All right, and now the next question in the regression. Again, we're gonna put this table in. So I'm gonna delete that. Plug in a new table. All right, and we're going to put our numbers, 10. Let me pause that, and I'll put the numbers for. All right, guys, so once again, you got your table. It is going to be a cubic equation, so I'm just going to go ahead and plug it in. It's 8x cubed. You're going to press 1 plus bx squared. You're going to press 1 for the table plus cx1 plus d. These are going to be your answers. It's asking you to round it up to the nearest 1,000. So the third place right here, third place of your decimal. So I'm going to write your equation right here. It is going to be 0.007 x cubed minus 0.832 x squared plus 52.683x and minus 266.743. Okay, so that is using these numbers right here. This is your B value. You're subtracting 83. The one gets rounded up to a 2. Here you're subtracting 52,683. And then here you're subtracting, and this 2 gets turned into a 3. Okay, now with the question, it is asking you, use your regression equation to predict a shuttle speed at 100. So we're going to plug in this 100 instead of the x. So once again, you are going to post this equation right here, y equals, you're going to put it with the new values of a, b, and c, so 0.07. And then instead of the x, you're going to put 100 and make sure you cube it. And then you're going to subtract 0.832. And again, put 100. And now you're going to square it. And then you're going to add the next value of c, which was 52.683, and going to multiply it by 100. And then at the end, you're going to subtract 266.743. And you're going to get 3,068.1.557. And that is your answer. So you're going to get 3,681.557 feet per second. Okay, because that is what your value is, okay? That's it. All right, and then moving on to the last 2 questions. This says using the multiplicity and the behavior, sketch the function. All right, so we're going to take everything and equal it to 0. So this x you divide by -2 is 0. Here you're going to have x plus 3 equals 0. So x equals -3. And the multiplicity is 2. And then last one, it's x minus 5 equals 0. So x equals 5, and the multiplicity, it's 1. Now you're going to next look at the leading coefficient, which is the -2 number right there. So the leading coefficient's negative, which means the function will end right here. Next, you're going to look at it and say, okay, what is the degree of my function, right? Is it going to be even or odd? How do I know that? Well, how many zeros do I have? I got 1, I got 2, 3, because there's 2 of them there. And then I got 4. What does that mean? It means the degree, it's 4. So I got 1, 2, 3, 4. 4 is an even degree. What does that tell you? That the other end will also go down. It has to, because it has to, the foots gotta go in the same direction. Next, we are going to graph the zeros. So here is a 0. At -3, it's a 0. Okay. And at 5, it's a 0. Next, we're going to go and do the multiplicity. So through a 5, we're just going to slide right through it, okay? Through a 0, we also going to slide right through it, okay? And then at -3, we're going to bounce it. So this is a multiplicity of 2, this is a multiplicity of 1, and this is multiplicity of 1. I always start with my negative leading coefficient or positive leading coefficient, okay? All right, and next one right here, you got x equals -1. I'm going to equal the x plus 1 to 0. Here, you're going to have x equals 4. And the multiplicity of 2. Here, it doesn't say, so that's 1. And here, you're going to have a x equals -4. Again, you flip the sign, and it's a multiplicity of 2. Okay, now next, you are going to look at the leading coefficient. There is no negative in the front. That means the leading coefficient is positive, okay? But what starts the equation in front of the parentheses has no sign, so that means it's positive, okay? Now, how many zeros do you have here? You're going to count your multiplicities. You got 1 right here, you got 2 right here, and you got 2 right here. That means 4, that's 5. That means the function's odd. That means that your end right here is going to also go in the opposite direction of what the positive leading coefficient. Now you're going to mark your zeros right here. You got -1 and a multiplicity of 1. You got a 4 multiplicity of 2, and you got a -4 multiplicity of 2. So these are going to be 2 bounces. So I'm going to start from my leading coefficient. I know that at 4, I'm going to have a bounce. So I'm going to go down and bounce it, okay? Now, next one on the list is -1. It says you're just going to slice it. And then at -4, you're going to bounce it again. And then you're going to end at your other end. So you got a multiplicity of 2 here, multiplicity of 1 here, and a multiplicity of 2 here, okay? And again, you can graph it to confirm, all right?